Welcome back. In this video we will be looking at parametric constraint. So parametric constraint is used to give some level of control and restriction to our work, though AutoCAD is not strictly a parametric software, and that is why most of the time we hardly make use of it in AutoCAD. But you might find this interesting by the time you see how it's being used, and it will help you to be and prepare you for other parametric software. So now when talking about parametric in AutoCAD, we have actually two types of the parametric constraint. So we have the geometric constraint. If I come to my parametric tab here, so I have the geometric constraint and the dimensional constraint. Now the geometric constraint is to control your the look, the shape of your object. It will help to put it in a perfect mode. While the dimensional constraint will affect the dimension, it will control your drawing, the dimension of your drawing. So whenever you input a new dimension, it will take effect immediately. So there's difference between our normal dimensioning and dimensional constraint. Now to start with, coming to this panel here, we have some features for geometry. So I have the coincident, the collinear, the concentric, the log, parallel, and the likes. Now to demonstrate that, probably I'll just draw some funny lines. Right now, to make use of, let me copy this. To start with, I want to make this line vertical. This is not well vertical. Like for instance, probably I want to draw a straight line and I drew something like this. Now if you zoom it, you know that this is not a vertical line. It's a bit slant, right? Also, this is not a perfect horizontal line. This is a bit slant. So to make this correction, I can come here, like this is for my vertical geometric constraint. So I'll click it, and it will ask me to pick the object, to select the object I want to apply the constraint on. So I will definitely want to apply it on this. So I'm going to click on it. Then you can see it makes it straight. If I should pick this object as well, it makes it vertical as well, much more vertical, right? Then for I have my horizontal. So if I apply it here, you see that the horizontal make it so straight, so right. Then I have what is called the concentric. So it will ask me to pick a circle. Concentric mean we have two circles and they will have to be at the same center. So I want this and this to have the same center. So I'll select the second object. So now they share the same center, right? Now we also have the coincident, right? So if I ask me to pick 2 points, I'll pick this point and this point. You see, join it together. Then collinear as well. If I pick, let me try this and this, so to bring them linear to each other. Then I have equal to. So equal to will take the same, it will make them equal. So for instance, I want this circle. So I want this circle to be equals to this. So I just pick equal to. Okay, let me use this. So I want this, then I'll select second object to be equals to this. You see that? That is Then I have tangent as well, so I can pick this. I say, oh, I want this to be tangential to this, so they are tangential to each other. So if I try to move this, it will move with it because they are tangential to each other. And whenever I have a two rough parts, then I can apply my smooth. So I'll pick here, also pick here, then it will give me the close up for it and this place is smooth, right? Then we also have this symmetric. So when we have an object that are symmetrical to each other, so you can decide to say, okay, I want this it to be symmetrical to one another. So I'll pick this, select this first object, then the second object, then it asks me to pick a symmetric line, so I'll pick this, so I have it, right? So this is about a parametric or geometry parametric. So let us look at an example on that. So let's draw some random objects. So I have something like this. Now let's work on it with our constraint. I'm going to my horizontal, I want this to be horizontal to each other. Then vertical, make this vertical. Let me increase the, then I want this vertical as well, right? Now I can use equal to, this should be equals to this, and this should be equal to this. Then I can use my coincidence. Yeah. Now I have a perfect square, so with my parametric constraint, geometrical part of it. Now the symbols on this are indicating that there are constraints on the objects that we've drawn, and your work can be fully constrained, under constraint, or over constraint. So for something like this, it is fully constrained. Now if it appeared that it looked rough, the whole constraint symbol look rough, so you can decide to show or hide the particular one and click hide, right? Or you can say you want to hide all, but that doesn't mean that the constraint is no more there. It's still there. If you look at this, it is there, right? So it's, and I can show all. Now I can auto constrain my work, but auto constraint won't really give me a good perfect work. So if I click here, I have the option to pick what I want to be displayed right out, and here if I want to make use my auto constraint, how it should be done, and in the order it should be done, right? I'll cancel that. Now let us look at dimensional constraint. So dimensional constraint will affect dimension. So if I have a straight line, right, or a rectangle, a cycle, so now I can apply dimensional constraint to them. So linear will affect it both horizontally. So if I want to apply this, so I'll click here, click this, then it's currently telling me that this dimension 1 is 6.339. So I can decide, looking at the length, just pay attention to this. So I can decide that I want the line to be 10, and I'll click enter. Can you see what happened? It increases the line, of which if I have a line something like this, and I use normal dimension. Let's say I have a normal dimension 6.707, and I double click to change my dimension to something like 10. Right, to 10. Can you see it does not change the length? So this is the one of the the proof for parametric constraint. If I double click again, I can decide to say, oh, I want this to be 7.5. Can you see that it will affect it in length, right? So I can use the same thing for my, and here I can decide to say, oh, I want my D2 to be D1 times 2. So that would be, my D1 is 7.5, so that was going to give me about 15. So you can see what happened. Yeah. Right, then I can now come here and use my equal to and say, oh, I want this place to be equal to this place. You see that? So meaning you can apply them simultaneously on the same drawing. So that is how it works. Then we have for align as well. If you have a drawing that is aligned, you can apply it to it. Circular as well, you can apply it circular for, so to give you diameter and radius, you'll be able to make your, so I can decide to say my diameter should be 2, it will increase it. Now if I click on this parameter manager, this is actually showing us some of the commands that I have input, right? So for this, it's telling us that, oh, we have 7.5, I have diameter of, I have dimension 2, this dimension here, of which it is my dimension 2 is D1 times 2. So this is it here. So I can decide to say, come here and say, okay, I do not want D1 times 2, I actually want D1 times 0.5, right? And I'll click enter. You see, that's reduced it. So I can control my figure with this parameter manager. Now we can delete a constraint of it. So by the time we delete the constraint, then it's gone. So for instance, where I have something like this, and before I'll be able to move this anywhere, right? But if I apply a fixed constraint on it, right, and I try to want to move it, it won't allow me. You see, it's only restricted to that point, only restricts me to that point. So but now if I should delete the constraint, okay, I want to delete the constraint on this, select it, enter. Now the constraint is gone, I'll be able to move it on it away rather. So if I apply it again and I say, oh, I want to hide the constraint, it's still there, right? But it's until I delete the constraint on it, that is when I can move it away. So we can delete constraint on either the geometric constraint or the dimensional constraint. So I hope with this video you'll be able to find your way on how you can make use of your parametric constraint. Thank you for watching. See you in the next video.